Hello class, so this video is going to be about the double angle identities. Here they are. I have sine of 2 theta, cosine of 2 theta, and then for tangent of 2 theta I said that that's irrelevant, at least just for now. In the future you may or may not end up using it, but just for the purposes of kind of simplifying and focusing, I'm just going to have us learn sine 2 theta and cosine 2 theta. Alright, so here are the identities. Notice that for cosine, there actually are 3 different forms. They're actually not too difficult to get from each other. Once you have the first one, and we'll prove that soon, then you can use some other stuff to get the other two. It's not too difficult to do that, you'll see what I mean. Alright. So, memorizing, again, don't have to necessarily memorize anything, because you can derive it all. So for the sum, for the sine of 2 theta one, we're going to use the sum identity. Pythagorean identities are going to be for simplifying the cosine 2 theta forms to be the other two. So let's just directly apply this. So 2 theta, I'm pretty sure we can all agree is the same as theta plus theta, right? Have a theta, have another theta, put it together, you get 2 theta. So this is the same thing, sine of theta plus theta. In other words, if we use the sum and difference formula, we get sine of theta times cosine of theta. So sine of the first angle times cosine of the second angle, which are the same in this case, plus cosine of the second angle times sine of the first angle. So sine times cosine is the same as cosine times sine. The order doesn't matter there, because it's multiplication. So how many of them do we have? We have 2 of them. They're being combined with addition. So we have 2 sine theta, cosine theta, and that proves the first identity up here. Right there. That's done. I'm going to put check marks later, so I'll erase that. Alright, so how about this? Let's literally just do the exact same thing. Cosine of theta plus theta. So our first angle is theta, second angle, also theta. Applying that, we got cosine of theta times cosine of theta minus sine of theta times sine of theta. Then we get cosine squared theta minus sine squared theta, and there we go. We have proven the second identity. So, done with those. Now let's prove the other forms of the second identity. So as long as you know this thing, so recall that sine squared plus cosine squared equals 1, you'll see that a lot. You should probably have that memorized by now. You can use sine squared theta equals 1 minus cosine squared, and cosine squared equals 1 minus sine squared. You can get that easily by subtracting things over to the other side. So let's work with that. So we are literally given that sine squared equals 1 minus cosine squared. Let's just work with that one right now. So we have cosine squared theta minus, and then now here's this quantity that we're subtracting, which is 1 minus cosine squared theta. So that equals cosine squared theta minus 1 plus cosine squared theta, because you're subtracting a negative. Got 2 cosine squared thetas there, so we get 2 times cosine squared theta minus 1, and we have proven the second form of the second identity. So I got that right there. Done. Not too bad, right? Once you can see that substitution, everything becomes easy. Well, now what do we have? We have cosine squared equals 1 minus sine squared. So what are we going to replace? Cosine squared. So with that, we are given, I'm just going to write it down here instead of next to it because of space. 1 minus sine squared theta minus sine squared theta. So if we combine that, the 1, nothing happens to it. Then we have minus sine squared minus sine squared. So we have minus sine squared twice. So we have minus 2 sine squared theta, and there, we are done with that as well. So basically, we use the sum identities to get the first forms. And there's really no other form for sine 2 theta, so that just stays there. Then use the Pythagorean identities to directly apply them to cosine of 2 theta and then get two other forms. These are useful in different cases. It's helpful to be able to recognize what's what. I usually remember it as cosine of 2 theta. The cosine itself is going to be the positive one all the time, and sine is going to be the negative one, because cosine and cosine, and then the negative one is the opposite one. That's kind of how I just look at it. If you find another way, feel free to use that. But yeah, so these are going to be useful for deriving the next two. The next two are actually related to each other, and they're going to be using this directly. Specifically, actually, these two are going to be applied for that in the next video.